Good morning, everyone. Before we start with our discussion on profit maximization, let me talk to you about derivatives. Derivatives is or are one of the basic cores of calculus, and it's like the rate of change of a function at a certain point. There are so many rules in derivatives, but we will just be focusing on two things that we will be applying in our discussion later. So first is that the derivative of a constant is always 0. Okay? So if you want to know the derivative of 18, the derivative of 18 is 0. The derivative of 1000 is 0. The derivative of 151 is 0. Okay? The next one is the power rule. Okay? So let's say this is the format of your power rule, which tells us that the first thing you need to do is you multiply this power here to your coefficient, and once you're done with it, you deduct 1. Okay, example, let's say x 4x raised to the third power. So the derivative, okay, of x is equal to 3 times 4, you have 12, x 3 minus 1 squared. Okay, so another example is 5y squared. So the derivative of that is 10y. So let me just ask you, what if it's 10z raised to the fourth power? How much now is the derivative? Very good. So it's 40 z cubed. Okay, now we can now proceed to our main topic, which is about profit maximization. Please do know that this is an interactive video, so please, every time I pause for a while, it means that you need to solve, okay, certain things, and that by now you should have already prepared your calculator, your ball pen, and your scratch paper. Let's start. Before, I've taught you how to derive the demand function equation, which is following the format: Q is equal to A plus BP. Q is your quantity demanded, A is your slope, A is your y-intercept, B is your slope, and P is your price. And there is an inverse format for this, which is P is equal to A plus BQ. And they're still the same. P is the price and Q is still quantity demanded. And we know that the slope eventually will become negative because of the inverse relationship between price and QD, and this is being presented in the law of demand. Now let's say that the demand function has been derived already, and you got Q is equal to 100 minus 5P. To solve for the profit maximizing price and profit maximizing quantity, we need to get the inverse format. Okay, so I will have to ask you, how are we gonna change Q is equal to 100 minus 5P into P is equal to A plus BQ? Very good. So this is what we're gonna do. We will transpose. So this will become positive 5P 100. Yapon will still be there, and then Q will be transposed to the other side. It will become negative Q. Okay, and we go then further by dividing both sides by 5. So this is P is equal to, please solve, very good. 100 minus divided by 5 is 20, and this is of course, has a coefficient of 1. So negative 1 divided by 5 is negative 0.2 q. So you now have your inverse demand function equation. So if you want to know what if the quantity demanded is 30, how much will be the price? Okay? So if you want to know the price given a certain quantity, you can use this function. So this is just our first step. The second step is finding total revenue. Total revenue is price times quantity. It's just like your sales in accounting. So P times Q. So this is a hint, class. To find the total revenue function, you can use the inverse demand function to get the TR function. Okay? So that is the clue. So what we're going to do is, you have to, can you write it down in your paper? Very good. You have to use 20 minus 0.2 Q instead of P times quantity. Okay, so maybe some of you are asking, Miss, I used 100 minus 5Q instead of Q, and then I just, maintained P. You can also do that, but as I have said, if you want to go further, if you want to know the price and the quantity that's going to give you the highest profit for your business, given a certain demand function, you have to use the inverse format. But if you just want to know the revenue, okay, you can just still apply the original demand function equation. Okay, so let's distribute 20 times Q, that's 20Q, and then negative 0.2 Q times Q is negative 0.2 Q squared. So that's TR. By the way, class, later on, if we are going to prove our answers, and if you want to know total revenue, you have two ways to solve for total revenue. The first one is you just simply multiply P times Q, and then the other one is that if you don't have any idea on how much P is, but you do know how much Q is, then you can just put it here in the TR function. Okay? Pero kung may P ka na, kung may Q ka pa, you just simply multiply. What if you just know the P, but you don't know the Q? So how are you gonna write P here when there is no P variable? So the first thing that you need to do is you imagine which among the functions available right now can you use to find Q first, because you cannot simply put the value of P here. Kaya again, wala gani P. So what you can do is you go back to this function. You know P, right? So you put the P here, so negative 5P, and then you get the quantity from there. Once you have the quantity, you have two choices now. You know the P, you know the Q, you just multiply P times Q. Or, okay, if you want to go for the complex method, once you know the Q, you use the Q here in your TR function. Okay? Anyway, let's move on. So you have your TR function. The next thing that we need to do is you find your profit function. Your profit function is total revenue minus total cost. Okay, it's just like in accounting. It's sales minus expenses. Total cost is made up of fixed costs and variable costs. Let's say that your total cost function is given, and that it is, let's say 100 plus 2Q. Your 100 is your fixed cost and your 2 is your variable cost. So every time your Q increases by 1, your variable cost increases by 2. This is the simplest because we know that there are so many factors that we can also consider to make a total cost function. So it can be more complex than this one. But for the sake of this particular discussion, so we have a very simple total cost function, which is given, by the way, okay, because I haven't taught you how to derive a total cost function. But anyway, let's proceed. So TR, that's 20Q minus 0.2Q squared. That's your TR here. And your TC is, let's enclose it in a parenthesis, 100 plus 2Q. Don't forget to enclose in a parenthesis, okay, because there is, you might encounter a problem later if you don't enclose it. You might, you might just end up writing negative 100 plus 2Q, when in fact, if you enclose it in a parenthesis, diba, this negative sign will be distributed sa 100 kag sa 2q. This will become negative. And this is the reason, class, why we are not using the regular demand function and why we're using the inverse one. Because ang TC mo is dependent on the quantity, right? On the number of, it's not dependent on the price, it's dependent on the quantity, the things that you have produced. So your cost will change depending on the quantities that you have produced. So, hindi pwedeng updon mo ang, okay, ang P, diba? Kaya if you're using 105P for your TR function, ang matabo, you have your P here, na variable sa TR, and you will have your Q na variable sa TC. You will have a more difficult time kay you have two variables now in your profit equation. Okay. So, let's try to simplify everything. Please do that in your notebook. Please take out the parentheses first, and then you simplify everything. And please write in sequence. Unahon gid ang may-ara ang gid-array sa power of 2 or more. Okay, very good. So let's take out the parentheses. 20q minus 0.2q squared minus 100 and then minus 2q. Okay, further, 20q minus 2q, that's 18q minus 0.2q squared minus 100. Okay, let's put it in sequence. So you have negative 0.2q squared plus 18q minus 100. What's this one? This is your profit function. So if you want to know how much will be your profit, if your quantity is 50, you can use this formula. You just simply put 50 in lieu of your Q. What's next? The next one is to know your marginal profit or the change in your profit. Kaya diba, derivative is the rate of change. So this is where we now apply derivative. So we now have to get the derivative of your profit with respect to Q. Okay, so let's like F prime profit. You can also write it like that. So anyway, the derivative of negative 0.2q squared. Remember the power rule? The first thing that we need to do is you multiply the power by the coefficient. So that's 2 times 0.2, right? So okay, so it's negative 0.4 now. And you deduct 1, diba? So it will become q na lang. Then, still power rule for 18q. This is raised to the power of 1, right? So 1 times 18, that's positive 18. But then if you deduct 1, wala naman mabilin. So q will now become 0. And finally, you remember the derivative of a constant. So the derivative of 100 is always 0. Okay, so this is now your marginal profit. And this tells you that the derivative of your profit function is negative 0.4q plus 18. We have to equate it to 0. So your marginal profit, this is your marginal profit function. You say marginal profit, this is the change in your profit every time there's a change in your quantity. Should be equal to 0. We are going to equate it to 0 to get the quantity that's going to give us the highest profit. So negative 0.4q plus 18, okay, please bear with my ball pen, is equal to 0. So let's 0.4q is equal to negative 18, right? Divide both sides by negative 0.4, negative 0.4. Your answer here is q is equal to 45. So what is this? This is the quantity that will give you the highest profit. Okay? Sorry, wala ko gali na pakita. So that's the quantity that's gonna give you the highest profit. And you cannot say nga, oh, if that's gonna give me the highest profit, then maybe I'll just put the price of 1,000 so that I can also get maybe it can give me a higher profit but it doesn't work that way. If your quantity is 45, then there's already this price that has determined 45 na mabaligya. So you have to find a price that will allow you to sell 45 pieces. So you have to go back to your demand function equation. Kay wala ka di iban nga function that will allow you to compute for P except for this one, right? So P is equal to 20 minus 0.2 times 45. Please find the profit maximizing price. Okay, the answer is 20 minus 9. The answer is 11. So if you sell, so this is the price that's gonna give you the highest profit. So if you will sell the product at 11 pesos, you will be able to sell 45 pieces, and from there you get the highest profit. But please take note that even if this combination is going to give you the highest profit, this may not give you the highest revenue. Revenue is different from profit. Revenue is as price times quantity. Let me prove that to you. I've actually computed for it. So let me show you. So let's say that the prices are 2, 5, 10, 11, and 12. And earlier, I did not write anything under Q or anything under TR, TC, and the profit function. But to save time, I'm gonna be just discussing to you how I did it. So first is, if this is just given and you don't know Q, you have to go back to one function that can help you identify Q. And the best function that can help you find Q is this function. Q is equal to 100 minus 5P. You just replace P with any value there. 2, 5, 10, 11, 12. So go back. 100 minus 5 times 2, that's 10. Okay, 100 minus 10, that's 90. 100 minus 5 times 5, that's 25. You have 75. So on and so forth until you complete it. And that's what I have mentioned earlier. If you want to know the TR, the total revenue, you have two ways. So what are the two ways? The first is P times Q. The second is get the quantity and then use the TR function. You replace Q with the values here. 90, 75, 45, 50, 40. Okay. But if you want your life to be less complicated, then you can just simply use P times Q because you already know your P and your quantity. So why complicate things? So 2 times 90, 180, 375, 500, 495, 480. Okay, so these are your total revenues based on your P and your Q. How about your total cost? Your total cost function was 100 plus 2Q. So you just simply put Q, you replace Q with 90, 75, 50, 45, or 40. So again, this is easier. So you have 280, 250, 200, 190, and 180. And to get the profit, syempre, you have to deduct total cost from total revenue. So 180 minus 280, that's negative 100. 375 minus 250, 125. 500 minus 200, that's 300. 495 minus 190, 395. Okay, and then 480 minus 180 is 300. Okay, so take a look at this. The highest revenue so far is 500, right? And the highest profit is 305. And you can see that there are different combinations of price and quantity that's going to give you a higher or the highest revenue and the highest profit. So therefore, we again conclude that even if 11 will give you the highest profit, it may not give you the highest revenue because it still depends on the total cost. Okay, so it's just 10 and 50 so far in this equation that will give you the highest, or in this table, because maybe it could be 9, it could be 8. We were not just able to explore that, but there's another way to find the revenue maximizing price and quantity. So the hint is, if you want to know, you get the derivative of your TR function. Where's your TR function? That's one. Get the derivative of your TR with respect to Q. If you know what the derivative of 20Q is, check it out. and the derivative of negative 0.2 q squared is, okay, check it. So you put it as a function and then you equate it to 0. You will be able to get the quantity that's going to give you the highest revenue. Okay, and if you want to know the price is going to give you the highest revenue, well, use your demand function equation. P is equal to 20 minus 0.2 q. But I will leave that to you to solve, and maybe you want to discuss with me when we see each other during our synchronous meeting how you were able to solve it. Again, the hint is, if you want to know if you want to prove that 10 is really the price is going to give you the highest revenue, okay, or if you want to know that there's another number that can give you the highest revenue, you get the derivative of your TR function. So basically you're getting your marginal revenue and you equate it to 0, and after you get the quantity, you get your price. Okay, so this is now the proof class that indeed 11 and 45 are the combinations that can give you the highest profit. Now, if you want to make your life, if you a little bit more complex, if you don't want to, or let us say the TC function is not given and that wala, diretsuhan ay find the quantity maximizing the profit maximizing quantity. Okay, diretso. But I have given you a profit function already. Or find the maximum profit gali, and then I have given you the profit function. Syempre, you cannot solve for the TC kaya wala ka man TC function, but you have the profit function. So this is what you're gonna do. Kung gusto mo budlay, amo na siya. So just replace Q with any quantity, with all of those quantities there. So put 90, 90, 90, or 75, 75, 75, 50, 50, 50. You will still be able to get 100, 125, 300, 305, and 300 using the profit function here. Again, do not use the the marginal profit function. Don't use this. The one nga ginkwaan mo sa derivative, that's marginal profit. You're gonna get a different answer. Do not use negative 0.4q plus 18. You use the original one to be able to get all of this. Okay, so for now, just try to review this video over and over again if you still can't understand this. And the next meeting, we're gonna have a synchronous discussion and maybe some more examples. Okay, thank you.